Now that we're behind the microscope, let's first introduce the hand panels. And the hand panels on a modern day microscope have a number of knobs and buttons that you would use in your daily operation. Now, you'll find on the hand panels buttons, you can find a trackball, you can find a knob that you can turn, and you can find a joystick. Now let's go from left to right over the hand panels and describe each button, knob or joystick briefly. So we start on the left side, and on the left side you will find two buttons that are called alpha tilt and beta tilt. Now the alpha tilt is used to control the specimen. So if we envision that this is our specimen and it sits between two chopsticks in the stage, and this is the tilt axis, what alpha tilt will do is it will tilt the sample alongside the tilt axis, like so. A beta tilt will tilt the sample perpendicular to that alpha tilt direction, like so. A beta tilt should not be confused with a in-plane rotation that is used for dual axis tomography, which is a 90-degree rotation, and that will be something like this. So alpha tilt is tilting along the tilt axis, and beta tilt is tilting perpendicular to the tilt axis. Beta tilt we do not use in cryo-electron microscopy. Now these buttons are pressure sensitive, and I'll demonstrate the alpha tilt because this microscope is not fitted with a beta tilt holder. So let's now push one of the buttons, and when you press strongly, you can see on the fluorescent screen that the stage tilts faster. And if I press it lightly, you'll see that the stage will tilt in a more slowly fashion. So the next button that we find is a trackball, which is this. And this trackball controls the beam itself. If we look at the fluorescent screen, we can see here the beam, and if we move the trackball, we move the beam. So this is for centering the beam during normal operation. And again, this trackball has a plus and a minus at the top. So when we press the plus, we will have coarse movement of the beam, and when we will want to have fine movement of the beam, we'll press minus, and then the beam moves slowly. Up is up, down is down, left is left, and right is right. So the next button that we find is the intensity button. This is a knob that we can turn, and intensity is the condenser 2 lens. And we can see in the UI, if you look at the C2 lens here, the indication shows the percentage of excitation of the lens. And when I turn clockwise, the excitation increases, so the strength of the lens increases, and when I turn counterclockwise, the strength of the lens decreases. Like with the trackball, also the intensity has a fine and a coarse adjustment. So again, with plus, the button behaves in a quick manner, so we will have fast movement of the intensity, and with fine, we will have slow movement. What you can also see is that when you turn this button clockwise or counterclockwise, at some point the beam is condensed to a single spot. The single spot is crossover. And we will see the behavior of the beam. On one side of crossover it spreads, and on the other side of crossover we see exactly the opposite, it spreads again. So turning this button counterclockwise condenses the beam to crossover and then spreads it again. And then turning it counterclockwise again condenses the beam to crossover and spreads it again. People will also use the term focusing the beam, and this is not to be confused with focusing the image. So focusing the beam to crossover, it will be the same as condensing the beam to crossover. The next two buttons are next to the intensity button. The top one is marked with exposure, and this exposure button, when we press this in older type microscopes, we would get an image on film plates. Now modern day microscopes have digital cameras and no film plates anymore equipped on the system, so therefore this button is doing nothing. The button below exposure is the stigmator button. So an image can be astigmatic, which we might want to correct. If we press stigmator, then you'll see in the user interface a stigmation panel popping up that shows you, in this case, the condenser stigmator and the objective stigmator. So now when we move to the other side of the hand panels, to this side, we will have the stage control. And the stage is controlled via a joystick and two buttons. And the stage has three axes, one in X direction, one in Y direction, which is controlled with the joystick, and one in height, which is controlled by the Z axis. Let's first demonstrate the X direction. So when we move the stage up, this is up in X, and when we move the stage down, this is down in X. And similar for the Y direction, if we move to the left, and when we move to the right, we move the stage in Y. This joystick can also be moved in a diagonal fashion, but most of the time we will use either X or Y, because that gives a more regular behavior. Then the Z-axis is height, and this height is used for setting eccentric height on the stage. This you cannot clearly see in an image on a microscope, but also here these buttons, similar as the alpha tilt, are pressure sensitive. So when we press this button, it will move in Z fast if we press strongly, and it will move slow if we press softly. You can see that the Z direction is changing, because below here you'll see the coordinates of the stage. We have X, Y and Z, and if we now watch the Z direction, and if I press this button, you'll see that the Z moves up in micrometers and down when I press this. And when I press lightly, you'll see that the stage moves, but then slowly. Next to the stage control, we will have the focus button. The focus button is a very important button on the microscope, as it will focus the image. When we turn the focus button, we will always turn the upper part of this button. This button is divided in two parts. We have a lower ring and we have an upper button. When we change the defocus, we'll turn the upper part. And similar as for the stage controls, where you have X, Y and Z, we will also have an indication of the defocus, which here says defocus, and you'll see the defocus in micrometers depicted over here. If we turn this button, you'll see that we change the defocus while we're turning the button. If we want to focus fast, we can change the focus step by changing the lower part of the focus button, which is the focus ring. And also that is indicated here. So you see focus step 1, and when we increase we can go to focus step 9, which is the maximum speed. Focus step 1 is going to be a very slow adjustment. So you'll see that here the defocus is going slowly. And focus step 9 will be the fastest, and then you'll see that the focus will change very fast. Be aware that step 9 is really coarse, and you can already see this in the image, that the image will change very dramatically. So watch out to not put a too high focus step on your defocus, because you might lose the image. If you've lost the image, so let's say we are at focus step 9 and we're very far from focus, like you can see here, there is an additional button on the control pads that will reset the defocus to a preset value that is set when the microscope is installed. And this is called eccentric focus. And this brings the focus plane to the eccentric height plane. So whenever you're lost, you can press this button, eccentric focus, and you'll see that the image returns back to normal and your image would be roughly in focus at the eccentric plane. So next to the eccentric focus button, we have a button which is marked with wobbler. And this wobbler is the focus wobbler, which will assist you in focusing the image. And what it does, it imposes a beam tilt, so it wobbles back and forth with a beam tilt. And as you can see, the image is moving when it is not in focus. So now when I'm turning the defocus button, you'll see that this movement becomes stronger, and when I turn the button the other side, you'll see that it moves in the other direction. But somewhere in the middle, the movement is minimized, and you can even make it stop. And that point would be focus. Next to the focus button, we have the magnification button. And the magnification button controls the entire projection system. When we turn the magnification button clockwise, we will increase the magnification, and when we turn it counterclockwise, we will decrease the magnification. The magnification on electron microscopes follow discrete steps, and the steps that can be followed are dependent on the configuration of your microscopes. Above the magnification button, we will have the diffraction button. The diffraction button brings the microscope in the state of imaging in diffraction mode. So pressing this button switches the microscope in diffraction mode, and since we were at low magnification, we will have now low angle diffraction. And if we switch back and press the button again, we go back to imaging mode, which is in low mag. If we increase the magnification to SA mode, like so, and we then press the diffraction button, it automatically goes into normal diffraction mode. When you're in diffraction mode, if you then turn the magnification, it controls the camera length. So similar as in imaging mode, when you turn the magnification button, you magnify the image. When you're in diffraction mode and you turn the magnification button, it changes the camera length and effectively magnifies the diffraction image that you see. So the final part of the control panels is in the middle, where we will find the multifunction knobs and we will find the multifunction buttons. The buttons, again, you can push, and the knobs you can turn. And these buttons are responsible for any function that you can find on the microscope. The word itself, multifunction, already says that. You can assign to each of these buttons and to each of these knobs a specific function on the microscope. Also, when you're aligning the microscope and you go through the different steps of the microscope itself will assign functions to these buttons that you would need during the alignment. Now, to set these functions, you can look at the user interface and you go to the bottom left corner, and here it will depict the MFX, which is the multifunction button X, the MFY, which is the multifunction button Y, and the left L1, L2, L3 multifunction buttons, and the right R1 to R3 multifunction buttons. And on the right side of these knobs and buttons, you'll find the function that is currently assigned to these buttons. So MFX says beam shift now, and MFY says beam shift. So currently, the multifunction buttons MFY and X have the same function as the tracker ball. And we can show that by again making the beam visible, so we're condensing the beam towards the spot. And if we now control the trackball, we see that we can shift the beam. However, if we now turn the multifunction button, we also move the beam. So MFY moves the beam up and down, and MFX moves the beam left and right. The buttons here on the left side, L1 now is assigned, for instance, screen lift. This lifts the screen up so that we can take an image on the digital camera that is below the flue screen. We'll have alpha wobble, which wobbles the stage, and most of the time the two functions that you will always find on the multifunction buttons here are spot size. So the intensity button here is controlling C2. Remember, spot size was controlling C1. So when we press spot size minus, you'll see that here it is marked spot size. It goes from 2 to 1. So now spot size 1 is selected, and if we press R1, we go up in spot size. And to see what the lens is doing, again you can watch here at C1, where we can see the current going through the lens, which is now 14%. And if we increase spot size, we go to 15%, we go to 16%. So you see that when you increase spot size, the current through the lens is increased. And when you decrease spot size with L3, you'll see that the current of the lens is again decreased. To assign different functions to these multifunction buttons and knobs, you simply go behind the particular button or knob that you want to change, and you right click there, and you then get a list of all the options that are available to you. So for instance, if you want to have switching between microprobe and nanoprobe, you press that and it will say toggle microprobe nanoprobe. So now this button, if you press it, will switch between microprobe and nanoprobe mode. If you want to have something else, again you right click in here and you, for instance, select reset the defocus. If you then left click on that function, you'll see that now this button is controlling the reset defocus function. The two multifunction knobs can also be controlled in a coarse and a fine fashion. So above multifunction knob X, you'll find a minus and a plus, and similar to the other minus and pluses, if you press plus, it will allow you to control this knob in a fast fashion or coarse fashion, and if you press the fine button, then when you turn the button, the function will move slowly. Above multifunction button Y, we have a button that is called dark field. And dark field is an application that is not generally used in cryo-electron microscopy, and we will therefore not discuss that here. A word on how to use knobs, and especially the multifunction knobs on the control panels. There's a different way to put your hands around a knob and turn it. So there are users that would turn a knob like this. There's also users that would turn the knob with a single finger. My personal preference is to use a single finger to turn the knob, and the reason for it is that when, for instance, you set the function quite coarse and you would turn it, you might quickly lose the beam. And if you use multiple fingers, you have lost track of where you started when you start turning this knob. And if you use a single finger, you can actually count in your head the amount of turns that you made with your finger, and you can place your finger, for instance, at the top of the knob when you start, and then exactly keep track on where you were. So for instance, if it's set quite coarse, and you can see now that the beam is moving quite coarse, if I place my finger at the top and I would turn and count in my head 1, 2, 3, 4, 5, I've completely lost the beam. And it can take a while for me to find this beam back. But since I remembered where I started, I can simply turn 1, 2, 3, 4, 5, and I have my beam back exactly where I began. So personally, when I control knobs, I have a tendency to do this with a single finger and remember where I started.